Welcome viewers, my name is Patrick Luck with StoneSoupProgramming.com, and today I am going to show you how to configure Spring Security to use Hibernate to authenticate users to your web application. And we're going to use the IntelliJ IDE and the Kotlin programming language put out by JetBrains also. So to get started, we're going to create a new project and we're going to use the Spring Initializer. This is a plugin used to create Spring Boot applications, and we're just going to go ahead and click Next, and we're going to call it com. Just give it a name, and then change it to Kotlin, so that way you can use the Kotlin programming language. You, of course, are welcome to use Java if that's more comfortable to you. And then you just click Next, and then we need some dependencies. We're going to need security. We're going to want web, so that way we have MVC. We're going to want the Timeleaf template engine. And then we want JPA, so that way we get our Hibernate dependency. And then we're going to want a database with embedded support, so that way we have a data store. And that should be everything we need for our dependencies. So I'm just going to go ahead and click Next here, and then Finish. And we will have IntelliJ generate a project for us. If you get this little dialog, just go ahead and add as Maven project. That way it knows to pull down the jars that you need. And then we can get started here. Okay, so the very first thing we're going to want to do is we're going to want to configure our applications.property file here, so that way it knows what to do with creating a data store. The first thing we want to do is set up the Spring JPA Hibernate.ddl auto and set it to create and drop. And what that's going to do is that's going to scan our code and look for any classes that are annotated with entity. And then it's going to just create a database definition language for us, which basically creates tables in our database and sets up the relationships and foreign keys. So that way we don't have to mess around with creating our database definition language for us. We also want to tell it to use Hibernate Spring Session Context. That way we can get a session factory in the code. And then we finally want this to use the appropriate JDBC driver. And that's all we have to do for an embedded data source. Spring will do the work of providing us with a data source. You could configure other properties if you wanted to use an external database, which is useful for both development and for production applications. But for our purposes, embedded will be fine. So now what we're going to want to do is we're going to want to head over to our Kotlin class, and we can get to the fun stuff. And the very first thing we're going to want to do is we're going to want to define some entities that map to our database. So we can use Kotlin's data class, and the first thing we want is roles, which serves for user roles in Spring Security. We're going to add our JPA annotations. So this is how they're done in Kotlin. So there's our primary key for roles. And let's see, I get a typo here. And it should import as we type it. The other thing we're going to do is we want to map this to its parent object, which we haven't wrote yet, but we're going to have a many-to-one relationship to a site user class. Now, right now it's going to complain because we haven't wrote that class yet, but that's okay. It'll hush up once we have that class. And then finally, we need a role field. And that's all we need for roles. The other thing we need is a site user class. We need to annotate this as entity also, so don't forget that. This is the annotation that tells our ORM to persist this object and manage its lifecycle for us. Now we need a site user class. And again, it needs annotations for our primary key. Now, the next fields are literally the same fields that come from the Spring Security user object. And you're going to see this, but basically, we're going to have username. Should be pretty self-explanatory. Password. Enabled is a field on the user class in Spring Security. Same with account. Non-expired. And I'm sorry, enabled should be a Boolean, not a string. You also have credentials, non-expired. And these fields can be used to fine-grain your security. We're not really going to use them here. We're just going to have them. But suppose you wanted to lock out a user because they entered the wrong password too many times. That would be a reason to use these. Or if you want to make them change their password after so many times, that would be another purpose of these fields. Now, the other thing we need to do for Hibernate purposes is we do need to map this back to our roles object. Now, the site user has a one-to-many relationship with roles. So we're going to do target entity roles class. It needs to be a mutatable set in Kotlin. And we can just default that to an empty mutable set. Now, one thing with the roles here is that the default in Hibernate is to lazily fetch any associations, so we're going to need to override that now. There's several ways to do it. I am a fan of the fetch profile strategy, so we're going to define a fetch profiles. We can call this one the default profile. And then we just set our fetch overrides. And if you didn't do this, you would get a lazy initialization exception later on when when Spring Security tries to authenticate a user. And all you're going to do is entity is our site user. You just tell the association what property, and then to get it to eagerly load, you just do fetch mode join. Now, what I like about this approach is that it's very flexible because you can have more than one fetch profile on a single entity class. There are certainly other ways to do this. For example, we could have just done fetch type eager, and that would have told it to eagerly load this. You could also use an HQL string, but that's not what we're going to do. Now, here's the thing. Spring Security is not going to work with our site user class, so we need a we need a method to mutate this into the Spring Security user object. So we're just going to write this toUser class, and that's going to be our user details user from Spring Security. And first we have to populate its authorities. And we can do that very easily. And we need a mutatable set of granted authority. That's a class that comes out of Spring Security again. We're just going to go through each of our roles here, pass it a lambda, and then we're going to create simple grant authority objects. And that's all we have to do for authorities. And then we can return a user class. And this is why I use the same fields that Spring Security's user uses, because now we can just pass it all the properties of our object here. Account non-expired, credentials non-expired, account non-locked, and then our authorities. And boom, just like that, our site user now becomes a Spring Security user. Now, the next thing we need is a path from our a database all the way up to Spring Security. So to do that, we're going to need a session factory object first. So let's create a bean definition for that. This is going to be a Spring configuration class. Now the cool thing is that Spring Boot is configured to work with Java Persistence API, JPA. So we can just inject an entity manager factory right into this class. And it's going to return a session factory. Let's just drop to the next line here. And all you have to do is call entity manager.unwrap and then tell it to unwrap a session factory class.java out of this. And then to make it injectable, we just need bean. Now, there are a lot of cases where you would want to use Java Persistent API over Hibernate. For example, JPA is a standard, so many developers are familiar with it. It is also allows you to switch out your object relational mapping libraries. In all practicality, though, I have never been on a project that switches out an ORM library. And so I just prefer to work with the Hibernate APIs directly because you do get some features in the vendor-specific API that you would not get otherwise. So now that we have a session factory that we can inject, we're going to need a repository class that would allow us to save and query users. So let's create a user repository class. And we're going to inject our session factory into it. Which is the bean we literally just defined. We're going to flag this as a repository so it gets picked up by Spring's component scanning. And the first thing we want to do is save a user to the database. So let's do that, save or update. And all we're going to do is call session factory, current session, save or update. And this is very brainless here. Now, the next thing we need to do, however, is Spring Security is going to query these users by username. So we should have a load by username. And what we're going to do here username string fetch profile string equals default. And this is going to load a site user. And what we're going to do here is we're going to call session factory, and we're going to use the criteria API. So session factory now what we want to do is set the fetch profile on it. So we use enable fetch profile, and we're going to pass it fetch profile. Because we used Kotlin's default arguments, it'll just load the default fetch profile for this class, so we can omit it later on. And then what we're going to want to do is set up a query. So we're going to use session.create criteria, and we're going to pass it site user Java class. Let's create an alias for it. And then we want to add some restrictions. And we're going to pass it that username as part of the query. We're going to return a unique result, and then we have to cast it as site user because criteria API is not typed. And that's all we have to do there. It would help to return it. Boom, just like that. Later on in the application, we're going to want to show all our users, so I'm just going to write up a quick method here that will return all the users in our data store. And this is going to return site user as a list. Same thing again, we're just going to grab a session from session factory, current session, set its fetch profile, which we can leave off because we are using default arguments, and then return session, create criteria, user, site user, Java class. And if you just do list, it will return everything, and then of course we have to cast this as list site user again, otherwise it'll fail compilation. And that's all we have to do for our repository class. Next thing we need is a service class. So let's create a user service class. We're going to inject our user repository into this class. The other thing is this class has to implement user detail service, otherwise it won't work with Spring Security. But before we do that, we want to mark this as transactional, which this is going to give us container managed transactions, which is something that we want. We also want to mark this as service so that it gets picked up in Spring's component scanning. And now we can override our methods. And it's that load by username right here. I'm going to take off the null safety because I can't imagine that we're ever going to get a null value here. And then what we do here is we call user repository load by username, just pass it the username. And then we call it to user, which if you remember that method above, we had this to user method up here. And this is where we're using it, just down here. And we actually could go to a method body, in this case, and one line it, which is one thing we love about Kotlin, is its conciseness. I'm also going to add two other methods. One's going to save or update our user. Now, this line is going to show you how to encode passwords, and the reason is we want to encrypt our passwords in the database, because if someone were to hack our database, they would have access to all our passwords, so it's very important that we encrypt passwords. We can do that very easily by setting the password property to bcrypt password encoder, create a new instance of it, encode user.password. Boom, now it's encrypted. That's all we have to do. Then user repository, save or update user. The other thing is we want to return all our users later on in the application, so we'll just do user repository all users, and that's all we need to do there. Now that we have a path to the database, we can configure our security, so let's do that next. And at this point, we can inject our user service into this class. This class does need to inherit web security configurator adapter. And then we just have to override two methods here. Configure authentication and configure HTTP security. So let's start with authentication. And all we have to do at this point is call authent user details service and pass it our user service object. We can do that because it implements user details services. And then we want to pass it a password encoder also, so password encoder. And we're just going to use that same bcrypt password encoder. And now Now our authentication can work with our database. We can take the null safety off because it's not necessary here. The other thing we're going to do is we're going to configure our web security for later on in the application here. So we're going to call form login. This has a chaining interface, HTTP basic, and then we're going to authorize requests, ant matchers. So we're going to have to log in for the display page. So we're going to call authenticated, and then any other request, we're just going to permit all. And that's all we have to do for our security. Now we're just going to write two controller classes. The first controller class is going to let us register a user with the application. So let's call register controller. And we're going to inject our user service into this class. Let's mark it as a controller. Let's map it to the register page. And we're going to have two methods here. We're going to have a doGet. And we're just using Spring's model view controller here, so it's going to get a model class. And we're going to add to our model a new instance of site user and return the register page so that it knows to render it. We have to map this to HTTP GET. We're also going to have a post method here in this class. This will let us save a new user into the data store. And we're going to call user service.save or update. We're just going to pass it site user. And at this point, we're going to want to actually redirect to our display page. So we use redirect display. We also have to map this to post. Just like that. And we have one final controller class here. And this class will be used for the display page to display all users. So we're going to inject our user service into it. Let's mark it as a controller. Map it to display. That's all we have to do there. It's only going to have one method, a doGet, which injects a model object. And this is where we're going to use user service.all users. Map it to get. So that's all we have to do for our Kotlin code. Now we just need two web pages. To make them, we need to put them in the templates folder. And let's start by making an HTML page. We're going to call it register.html. So the first thing we have to do is we have to make this into an XML document. And TimeLeaf is very fussy about these things being well formed, so we have to have closing tags or it's going to complain. Mostly speaking, these TimeLeaf pages are pretty much in HTML. And I'm going to add two dependencies. I'm going to add jQuery and Bootstrap. That way they're nice and pretty. Now we're going to create a form. And we're going to decorate it with time leaf tags, so th action. And we're going to map this to the register. So that way our controller class, this forwards this request to the appropriate class. We also need a th object, which is an instance of our site user class. Okay. Register a user. And then we also have to map our input tag to the field on our object. And that's what we're going to do here. It uses this star syntax. So that literally maps to site user username right there, if you see on the left. Very important that we close our input tag, or it will complain vocally and loudly. So that's our username. Now let's do our password. And that's the only two fields we're going to do on this, by the way, just to keep the example simple. And change that type to secret. Don't change that type to password, I'm sorry. And then map it to the password property on our site user object. And that's what we're going to do on this page. Our other page is a display.html, and this is going to show all the users in our data stores. Now for simplicity's sake, I'm just going to copy and paste over our code, and all I'm going to do is just update the body here. So let's create a table. And we're just going to show username and password. And then in the body, we're going to draw out a row for each user in our database. So tr with th each. All right, that looks correct. Now we're just going to make two cells. All right, and that's our web code. So now comes the fun part, where we start our application, and if all goes well, it will start right. And there you go. Now you can see the application starting up. If you watch the console closely, you'll see verbiage about it creating tables. And now our application's ready. So let's open up Safari. And we're going to point to localhost register. Okay. So if you get errors like this, chances are there's something in your document. And sure enough, I forgot to close the link. And this is what I was saying, that TimeLeaf expects these pages to be well-formed XML. So if we bounce our application server, all right, now let's try again. There we go. There's our user form. So let's just do Bob. Click Submit. Now, you see that it redirected to our display page, but that's authenticated, so we have to authenticate. And there we go. There's our user, and there's his encrypted password. So as you can see, it's very easy to plug Spring Security into a Hibernate database. Took very little effort to do it. Please visit me at the blog, stonesoupprogramming.com, for a text example, and you can also download the source code for the site at that page. And thanks for viewing, and until next time, happy programming.